Or you can just keep silent, right?
that too. Hello, everyone. Today is July 26, 2021. This is a meeting of the SIG Network Policy API subgroup of SIG Network. This is a CNCF certified meeting, so please be nice to each other and let's have a good meeting today. So I already looked at the issues. Again, no new issues to triage this week. Usually pretty simple. SIG Network picks most of them up. And there's none pertaining to network policy. So we're just there to help out if there are any, but didn't see any good new ones that concerned us today. I think the main action item on the agenda today is going to revolve around more CMP discussion to try to, ensure we have the user stories ironed out for the various action types and proposed actions that we already have. So we want to start coming to a conclusion on those, I think, here in the next week or two, so that we can keep moving forward with that KEP. Is there anything else anyone wants to bring up before we get started with CMP? Because it will probably go for a little bit. Going once, going twice. Sold. Okay, well, let's hop straight into it then, unless I'm forgetting anything. Yang or Abhishek, do you want to get us started with what y'all put together for today? And if you want to share.
Sure. Probably you need to enable sharing.
Yeah, I'll make you a co-host, Abhishek. Okay, you should be able to do it now.
All right, let me show. Let's see. Are you able to see the slides?
Yep.
All right. Okay, I think we added, Yang and I added some of the use cases that we thought about and added a bit more specific user stories. And then, we thought that probably it would be a good idea to go through the sample specs for, for different kind of approaches. And then we can see first whether all approaches are able to solve all use cases. And if yes, then we will see which sample spec seems more intuitive to write, more easier to consume from a user's perspective. And then we can hopefully make an informed decision in terms of which proposal the group wants to move forward with. So just to give a quick overview, and feel free to interject in between folks, and if you want to ask more questions or if there is something that we have not included here. And so on a high level, these are the use cases that we think, and we try to make them a bit more specific. So the first one was something that we spoke about was a strict deny. That is, an administrator may perhaps want to strictly isolate certain malicious pods within the cluster. So for example, you have detected that these set of pods are kind of having some malicious activity, and you would want to lock them down. So the administrator should be able to write a deny rule, which kind of like trumps every other rule, and they should be able to isolate such workloads. So a specific example would be, you've labeled these pods as type malicious, and they're probably in a namespace called, let's say, isolate me.
Yes, a stupid question. The namespace is just what it is, right? From the user, it's not, you're not moving things into a new namespace.
No, yeah. I just didn't have great names for it. This was just as an example.
But the type is a marking.
But they could label them, yes.
Yeah, exactly. The operator would go in and basically have the rule, and then just go in and label them as type malicious, and the rule will probably say all namespaces, basically all pods of type malicious will be denied always.
Yeah. Yeah, that's most likely what would happen. I just wanted to give a bit more specific use case, but yes, definitely the more realistic would be the pod would be labeled with certain special label, and then you will just apply this rule to all pods which have carry this label. Perhaps they could be from all namespaces, and you could also specify them. So, but yes, you're correct in your understanding. The second.
On 1A, right? Is it isolating from other namespaces or within the namespace also?
Now, the idea would be to isolate the entire pod. So you don't want, it should be from all namespaces, including
both ingress and egress.
Correct.
Yeah.
Correct. Yeah.
Okay. So basically, even in the other pods in the same namespace also won't be able to talk to them.
And since we don't do IP blocks, that is then DNS and talking to the API server basically completely freeze them.
Okay.
Yeah, well, yes, question. I mean, that's
so this is one correction. This is not saying you have to necessarily completely isolate. You can have any number of isolation options. So you can say that it is either completely isolated, or you can say that it is isolated except from this monitoring pod, which I've launched into this namespace. So this is a deny to the extent that the admin.
No, of course it was more.
Not saying that it implies it has to be fully isolated.
My question more: should we be able to isolate things from reaching the API server, DNS, and so on? That was more the question. Not saying that it's all like that.
Yes.
Yeah. So I think this is one specific use case, and of course you can have like a lot of combinations of these use cases. So you could have a strict deny, but you could run exceptions, and then we will go through all of those other use cases as well. And of course, in real deployment, I think the administrator would be looking at solving a combination of these use cases, or perhaps all of the use cases.
Exactly. You would have a number of policies, and then you would just apply them.
Yes. Yeah. So you could either have a number of policies to do them, or you could have a single policy to do them. You can just edit the current. So we should be able to provide that flexibility.
Yes.
So Abhishek, why there is a special type?
Oh, this is just to, let's say you've detected that, yeah, this is an example. This is a label. So let's say you've detected certain pods are acting maliciously, and now you would want to isolate those pods. So you want to be able to group them, and typically you would group them as label selectors. So that's why, as an example, we have said that these malicious pods will be labeled with type malicious.
So I mean, just
I think my question is rather, let's say, instead of let's say foo equal, type equal to foo, then you would be denying them, right?
Correct.
So I mean, it's just a deny. There is no special thing called a type, malicious or something like that.
So
you're reading it exactly as I did. This is an example. This is not the policy. It's a use case. If you want to write a rule, so you can isolate pods that you have labeled with type malicious from a namespace called isolate me, then that should work. I read it completely backward that you had a policy that looked like this.
Yes, this is not yet a policy. This is just a use case.
Yeah.
You don't necessarily have to have this type malicious label. You may have an identifier for the pods already. Let's say all your pods of app front end are acting weirdly. So if you already have a way to group them, then you reuse that.
The use case would be isolate compromised pods, and then sort of set the label type a malicious on them, and sort of then either have already a policy that acts on that, or I mean, the problem is, right, someone if a user had used this type malicious then as a label, then fun things would happen, right? So how do you clear a specific label combination so that the user don't use it by mistake. If I implement a firewall and I want to have certain pods that sort of works on malicious traffic, maybe I would call it type:malicious, right? So there needs to be some rules on that.
No, I think, the way actually, initially I thought there is a type called malicious, but right now the way I'm reading it is you have a label called, foo equal to bar, then you use the deny rules with the foo equal to bar, right?
Yes.
So,
Yes.
so it's like just a deny policy. I mean, maybe malicious is I don't know whether it is a, broad enough example. You just wanted to, restrict or deny certain things. If I understood correctly, Abhishek?
Yes.
Yeah.
It does.
Okay.
Sorry, go ahead.
Yeah, I think,
So-
I think, terming that as a type malicious and isolate me, is narrowing the scope. At least the way I put it is like, I just wanted to deny certain labels or certain regular expression of labels with a deny, deny action. And
Yeah, so
it just happened to be your label is type equal to malicious. I could have a type of foo equal to bar. And the namespace could be like, XYZ.
yes, I mean, I think we all kind of agree that so basically this is just to give a more specific example so that we can write specific policies to demonstrate the API. But you could, this is not a necessity that the label must be this. It's app foo bar, whatever is the label. However you identify these compromised pods, you should be able to isolate them. I think that's the use case.
Yeah, I mean, at least, in my view, maybe I would change the, example saying that, or maybe add another example saying that, like, you wanted to deny certain set of selected pods, by type equal to foo and, namespace equal to XYZ would be the second example, so that people won't like, divert themselves into type malicious or like, isolate me kind of a thing.
Sure, we can update the example to what you suggested.
Thank you.
Are there any special rules for when a, call it, operator starts label pods? Does it have its own, I don't know what to call it, but label namespace for this? It can be separated for labels that a user can put, be that in types or anything, so we don't get collisions. That's nothing really to do with policies, but more like Kubernetes.
For namespaces?
No, sort of not namespace, but sort of, you had this example with a type malicious, right? Maybe I use it in my application because I'm doing something. So how do you ensure sort of that things that an operator might want to tag a pod with is separated from the tags?
Yeah, I think
the user might
typically an
Yeah,
I think I understand your question. I think typically a user or operators may have their own predefined prefixes to label keys, and they can use that so that application owners do not handle those labels.
they have basically, and then just use the RBAC that you cannot set them.
Yes, you could enforce that so that, for example, Kubernetes.io is a reserved space as a label prefix, ideally. So similarly, and the operators may have their own. But anyway, I think the idea is not how to label the pods or namespaces. This is just an example. I think the idea is to how, but definitely we will update
I understand
label.
that sort of sometimes by being, I wouldn't say unclear, but sort of leaving things open for interpretation, you create more questions than, like in this case, you create more questions than you thought.
Yeah, but it's good to get that feedback so that we use the correct set of labels to make sure that it's widely understood.
And in your defense, it's really hard to name. It's really hard to come up with label names like on the spot.
So just to give one example of at least the way Contrail was doing is, so we have predefined labels like application deployment and etc. So for certain of our customers, like when if, let's say they are finding the DDoS attacks using the analytics engine. So what we used to do is like we used to a label called I don't remember, malicious or whatever that label. So we pick that label and user goes and modifies based on the analytics, whatever it was churning. So then what happened is, as Per mentioned, somebody was trying to use that same label to manipulate things. So then what we did is we put that tag into, or we call it as a tag, right? Here it is a label. That label is a predefined label rather than a regular regular label. So I don't know if maybe it goes beyond this example, but if we want, like we can have a predefined tags or predefined labels.
Yeah, I think that's beyond the scope of policies and network policies.
True,
The idea is that the administrator can uniquely identify this group of pods which are compromised, and then they should be able to apply rules for them.
Yeah, I think if that is the way, maybe, I mean, as you agreed, like we can change that content so that it won't divert us into malicious thing.
Got it. So I'll take that action item. But for today's discussion, let's consider this because the samples are based on this, and I believe Sanjeev also has the same set of.
Got it. Yeah, thank you.
The next one is a strict allow. So within a cluster, you would want to allow your workloads to be able to talk to core DNS pods, and assuming they are labeled with, I think they are labeled with K, it's app core DNS, but let's assume that they all come up with app core DNS labels. And so as a specific example here is, I want to allow traffic from core DNS pods, which are labeled app core DNS, from the kube system namespace, and allow system namespaces, which is named, let's say, monitoring in this case. So this is essentially, you want all your pods to be able to talk to core DNS and your namespace monitoring. The third use case is to
sorry, is discussed already. What's the reason you're making it as a strict? I mean, why that qualification? Like, can't we say deny, allow?
We are not discussing implementation here. We are just talking about use cases. And I think then we can go into the implementation. So at least we should agree that these are use cases which are valid, and this is possibility. And then we can probably look at different ways of solving these use cases.
Okay. Yeah, I think, what I was wondering is why is a strict qualification there, or qualifier? Isn't it just a deny, allow, deny but strict, deny but allow with exceptions?
I think the strict comes in because even a namespace admin will not be override this.
Oh, I see.
That's correct.
Okay. Sorry, I think I missed, last conversation.
Yeah, so to re-emphasize on the fact that when we say strict something, it essentially means that the cluster administrator's rules are enforced before namespace owners. So namespace owners cannot override these rules.
Got it.
Yeah, should have clarified that earlier. Thanks for bringing it up. So yeah, so that's the
one small point on this, and let's continue. But our initial sort of basic assumption was all of the cluster admins policies take priority over the namespace, right? So in effect, they're all strict because every one of the, we can come back to there's a subtle point about the strictness at the source versus destination, but the fundamental point was that a cluster network policy by definition implies everything in a cluster network policy takes precedence over namespace network policy. At least that's what we had earlier. Now, if we want to change that, we can sort of do it the right way. So yeah, I'm just mentioning that.
I think from the get-go, we wanted to solve two set of broad use cases. One where cluster administrators are able to define the stricter rules which cannot be overridden by namespace owners. And then there are certain set of rules which the cluster administrator wants to provide as baseline rules, which can be overridden by the namespace owners. And so this was from the beginning, and I think it's also part of the KEP. So that's why we make the differences, or rather we add the keyword strict here to denote that certain policies or certain rules are meant to be not overridden, while certain others use cases could also mean that I would want namespace owners to write network policies to override them. If not, then it should be denied, or whatever the default policy is.
Let's keep going. Yeah.
The third use case is you have this stricter deny, but you would want to have some exceptions to this deny, and you want to allow those exceptions. So essentially, this is like a subset of rules which should be skipped or accepted from the deny rule, and then they should be allowed. This traffic should be allowed. So a specific example is, let's say you want to do namespace isolation. And in this case, you want to deny all of that inter namespace traffic. So namespace A should not be talking to namespace B, but you want to give some exceptions to this rule. That is, namespace A should still be able to talk to the system namespace, like STO system monitoring and kube system. And then it should also be able to allow traffic to certain pods in other namespaces like core DNS. So this is one example of strict deny, but allow certain exceptions within this deny. Is this example clear? Okay. Moving on to the next one, which is strict deny but delegate. Now the difference here is, in both cases we are actually giving we are actually allowing the administrator to write some exception rules to the deny. But in this particular case, you are actually delegating the disposition for this traffic to the namespace owners. So as an example, you have defined a strict deny for the inter namespace traffic. That is, namespace A cannot talk to namespace B. But perhaps you have a public service in a certain different namespace, let's say public namespace. You would want all your namespaces to decide whether they want to access this public service or not. You don't want to make that deny or allow disposition for this traffic. You want your namespace owners, or you want to delegate that traffic to the namespace owners, and the namespace owners can then write Kubernetes network policies to either allow this traffic or simply isolate these traffic to these set of services.
So two things here. One more. One is again, this is hence not a strict deny because it is not enforced by the CNP. If you're delegating, then you're not being strict.
No, the strict deny is for the inter namespace traffic, but you're providing exceptions to those inter namespace traffic deny rules for public service. So the delegation is only for the public service. For every other inter namespace traffic, you want to do a strict deny.
Yeah. So some of these are there is a certain assumption of a tenancy model here, which I think we've got.
Okay. I think maybe to take a step back, here the tenancy model we are assuming is 1:1, one namespace, one tenant. We could also make it more generic by saying that one tenant can own multiple namespaces, and we should be able to solve the same.
So that's that's not what I was going. So none of that was going. I mean, I documented the tenancy model, so I know exactly what we're talking about, and it has nothing to do with 1:1 versus 1:n, which is true, but that's not the point I was trying to make. The point here is about whether the admin needs to know what kind of communication patterns are valid and what kind of communication patterns are invalid, so that you can decide whether to monitor for the valid traffic patterns, right? If the admin, normally an admin needs to know, these are my officially allowed traffic patterns, and these are my, right? So that's where I was going with it. So that's where I was going with the tenancy model. That even with that, there has to be a clear understanding of what should the tenancy, does the tenancy admin not know or not care which are the exceptions that are happening to the tenancy boundaries, right? Because basically we're saying that some clients are violating some tenancy boundaries and that's not visible to the tenant admin, or that's not controllable directly by the tenant admin because they decide how much of the tenancy boundary to violate. So it's a nuanced point. Let's go, because we want to make sure you get through your slides. So let's keep going. But what I wanted to say was that's an aspect of the tenancy model that there's been a little bit of vagueness on. And let's
we can address the tenancy model later. But is there a confusion in this user story or this set of user stories?
Yeah.
Like, is it clear between 3 and 4? What is the difference?
For me, it's not clear. Abhishek, can you expand on 4?
Yes. So on 4A, okay. So let's assume that in your cluster, you have a namespace which is called public namespace, and you have a service which is called a public service in this namespace. As an administrator, you would want all your tenants to access this public service, or maybe not. Depends on whether the namespace owner wants to access or not. So let's say I have a namespace called Abhishek namespace, and I don't really care about the public service namespace, so I do not want my pods to be talking to this public service. On the other hand, Young has his own namespace and he wants to access public service. Now, as a cluster administrator, I want to make sure that Abhishek's namespace does not talk to Young's namespace, but I let Abhishek decide whether he wants to access the public service from public namespace, and Yang decide whether he wants to access public service to public namespace. So this is like a delegation for this particular traffic to both Yang and Abhishek as namespace owners. But for inter namespace traffic for other namespaces, I want to strictly deny them, which means I cannot write any rule to talk to services offered by Young's namespace. Is it clearer now? Or
okay, yeah, I think I got the use case, but I think okay, maybe I'll think a little more and give the proper comments. Yeah, go ahead.
Anyone else wants to chime in or wants to?
Abhishek, this is Vinay again.
Hi.
The same question that I think we were asking. So the name that you're using for pub/service, these are not.
These are placeholders.
Okay, got it. Okay, thank you.
Yeah, these are all placeholders. Assuming you have this service.
Okay,
This is just because because if you want to write some specific YAMLs, you wanted to use some names and some labels. So yeah.
Got it. Thank you.
Right. So that's 4A. 4. Yeah. Right. Sorry.
I'm sorry to come back on 4A. So the use case of 4A is coming because see, this is becoming a very different intersection between 3, which is already intersection with 1. So having a deny and allowing some subset of that as an exception, that probably is easier to understand. But 4A, you're saying that we will be creating a strict deny as a superset, but as only a subset we want to delegate to the namespace admin.
Correct.
So Abhishek, I think here's the thing, right? Actually, maybe I'm saying the same thing, but I'll let you finish because you started this point. So go ahead.
No, I think yeah, I just wanted to make sure that is the case, and yeah, Abhishek accepted. But I still feel that case is. I mean, there are multiple ways to do it. If I mean, one way is to definitely rewrite your deny rule. But I mean, I made my point, so I can you can go ahead.
Yeah, so I had actually introduced this use case, but it was a slightly different version of this when I first introduced it, which is in that policy APIs repo, right? In the user stories repo. Although something similar might have been in the original CAPE as well. I mean, we've had so many use cases. So the thought at that time was that this is a tenancy model which is controlled by and visible to the admin. So even if you have to make an exception, the exception is also visible and possibly controlled by the admin. But now we have slightly changed it, which is that the tenancy is controlled and visible to the admin, but the exceptions are not. And we don't have a real world validation of what is the operational model in which that happens. Because what it does is the admin is not sure whether a certain flow is a validly allowed flow because it is crossing a tenancy boundary, or whether it is not a valid flow because tenants are supposed to be isolated, but there are some exceptions which I don't know, right? The admin doesn't know which are the exceptions. So
does the admin write the rules though? I mean, if you write the rules, you know the exceptions. I'm just trying to understand what you're saying there.
Right. I think
if the admin knew the rules, he would just put it in the CNP. The admin is saying,
Sanjeev, this is Vinay. I just want to make one point, right? I think I agree where you're going with, but shouldn't the issue about who wants to talk to what, shouldn't that be delegated to the namespaces? So like what we're saying is the cluster level, we're creating the guardrails. The guardrails are like, then individually under the namespaces, they can figure out if they want to allow. I think that is the delegation part, right? I mean, namespaces can write policies that circumvent these deny rules. But if the cluster network, the cluster admin has complete visibility, then we don't have delegation to the namespaces, right? I mean, everything is now handled by the cluster network admin.
Yeah, so that's why there is a risk that we could end up spending a lot of time on it, and I want to make sure that Abhishek gets time to go through all. I'll just mention one point here, which is that your original point, yeah, I mean, intra namespace and intra tenant traffic is already completely under the namespace users control, right? So what we have agreed,
but we still need to, administrator still needs to delegate that intra namespace traffic to the developer.
He delegates it by just not having a policy to it. So implicitly, what I don't control, I let you control, right? So basically the point is, if I care about it, then I have a policy because I'm super user, I'm the admin. If I don't care about it, I don't have a policy. You do what you want with it. But if I have something which is in between,
that is delegation, right? That is what we are trying to.
Delegation already happens anytime you just don't force.
That's one way of implementing it. That's one way of implementing it. But we are not talking about implementation here. Our point is to get a consensus on whether these use cases make sense or not.
I'm not talking about implementation either. And again, let's face it, this.
But if you're saying that if you are not
let me finish my sentence. So the point again, this was not implementation. This was about the actual operational model, right?
But you are agreeing that you would want to delegate traffic to namespace owners, and you would want to have some denies, and your certain denies could be a whole set of list. And then within that list, you want to provide some delegation for a subset of that list. See, that is a valid use case, right?
Well, do we?
Is it valid in some sense or not? It doesn't have to be valid for all use cases. At least is it a valid subset of use cases? And I think we should solve those use cases then. Right.
So I just okay. So now I understand it more clearly after your discussion, but I'm still a little bit confused because of the naming. So what I understood is this 4A is basically kind of a weak deny. Not, I mean, if namespace admin allows the traffic, then they can allow it. But if they don't, by default, it will fall back to these denies. Is that correct?
No, no. So let's take a example of Kubernetes network policies. We have IP block today, right? In the IP block, there's a accept side. So people have used CIDR, and then you accept a subset of that CIDR by doing an accept call, right? The accept does not say that you're denying that traffic. You're actually just delegating it to a next namespace or policy rule. So until and unless someone actually explicitly denies or isolates it, your traffic should be allowed. So this is sort of an exception. It's you think of like a giant set of a giant set of IP addresses that are denied, and within those set of IP addresses, there's a small subset which you want your namespace owners to either allow or deny.
Oh, okay.
I mean, this is a crude way of explaining that.
So Abhishek, I don't know whether I mean, just wanted to recap to understand, right? Let's say I have A to B traffic, and B consists of like B1 to B10, and you wanted to say A to B deny except B9 and B10, and B9 and B10's fate would be driven by the namespace admin to say B9 and B10, whatever he wants.
Correct.
Okay.
So
but why do we call it delegate? It's just an exception, right?
Yeah, I think maybe the wording
it is
should change.
The delegate is to kind of like have that difference between 3A and 4A. Because in 3A, you are strictly allowing the exception. So let's say, taking your example, A to B. Let's say B9, you want to allow. You do not want to let namespace owners decide that. So that's an accepting and allow. So that's 3A. And B10 is something that you want to let your namespace owner decide. So that's delegating. So just to...
Okay, so Abhishek, so let me jump in on this point, which is what I was trying to raise earlier, but I was deferring, but figured we are anyway going on a tangent now, so might as well throw this one in as well. When we do, remember that there are two parts to any allow or deny, right? What you do at the source and what you do at the destination, right? So if you want to have a policy where you want to defer, there are two major things that we haven't yet talked about or in most of our discussions of CNP. I'll mention the first one now and the second one later. The first one now is that whenever we talk about these strict denies allows, we haven't talked about whether these are enforced both at the source and the destination, or only at the source or only the destination. So for example,
the direction takes care of that, right? I mean,
yeah. So that's what I'm saying. Yes. So what I'm saying is, with taking into direction, again, the loose deny versus the strict deny can be handled with that already. For example, if you want to say that I want to let I want to let this particular service cross tenant boundaries, you can put an allow at the source, but at the destination can choose to deny it or allow it. That's your way of deferring it, right?
Yeah. But Sanjeev, I mean, see, the premises is like, do we agree, even in the egress, right? Do we agree you wanted to give an exception for B9 and B10 in a given A to B deny? Right? I mean, see, even it could be still ingress. Egress business is a different business anyway.
Yeah.
So I mean, are we agreeing that like, you wanted to allow exception even in egressing? That's
yeah. And again, so
I think we're going a little bit on a tangent.
Yeah, that's a tangent.
I think we need to just look. We have 18 minutes left, y'all. I think what Abhishek and what everyone else wants is like, are these valid use cases? So there's all these different arguments around in the implementation side of these use cases, and I think we've been kind of diving into them. But the clarity level, which has been brought up a couple of times, that's important. Like, we want to hear, like, are these use cases clear? A, and then B, do we agree? So we haven't even gotten to the YAMLs yet, but I think if we could just let Abhishek talk for a little bit. If we have any more concerns about understanding what the use cases are saying, not arguments about the use cases, just understanding what they're saying, and whether or not we agree, we should move forward that way. Does everyone agree?
Yeah, I think, I mean, at least, in my mind, till this discussion, right, I didn't understand what is the, deny and delegate. So maybe,
Right.
we need to have a, little more different, descriptions,
Yeah.
to give some more clarity.
Yeah.
So is
But
then Abhishek, then 4A is basically a more sophisticated way of writing one, basically strict deny, but instead of having only label, you can have some kind of exceptions.
Yeah, I agree with that. Yeah.
Yeah, I mean, it's about how you want to write it. That's a different story. But I think the intention here is to at least understand these use cases, whether these are valid use cases, right? So, and that's what I want to get a message from you guys is that is 3A and the differences between 3 and 4 clear to everyone? Like the intention should be clear at least, and then we can. Once the intentions are clear, I think it's easier to read the right YAMLs and proposals.
Yeah, I think it's clear. It's just the naming was a little,
I agree.
Little confusing to me, but otherwise, now it's clear.
But at least the intention between the 3 and number 4 is clear, right? In one case, it's a strict deny, but you have poking some holes to allow. In the other case, those holes are not really allowing; they are just being delegated to the namespace. So those seem like the intention is clear, right? At least now. Okay.
Yeah.
Cool.
So why it is named as only inter namespace?
Yeah. So just to talk about 4B now. So in 4B, so let's say inter namespace is basically traffic between namespace 1 to namespace 2 or namespace A to B, right? And as an administrator, my tenancy model here, let's say, is 1:1. We can solve the other tenancy models as well. But let's simplify the scope here. 1:1 tenancy model. I want strict isolation between namespace A and namespace B, or any other namespace that comes up. Every namespace that will be created in my cluster, I should have like a guarantee of that isolation that no other namespace can communicate, or this namespace cannot communicate outside of my namespace. So that traffic is called inter namespace traffic. The intra namespace traffic is basically anything within that namespace. So within namespace A, how I want my traffic to talk, like how I want my workloads to talk to each other, is the responsibility of the namespace owner. The administrator doesn't really care. So let's say you as a owner of namespace A would want certain services to talk to certain other services within your own namespace and isolate certain other services. So that should be, you should be able to do that. And it should not be like a cluster administrator has said, inter namespace traffic should be denied, but intra namespace traffic should be allowed. Now, since the CNP's rules are, the allow rules are strict in the sense that they cannot be overridden, you will never have an opportunity to isolate certain workloads within your namespace. We don't want that. We want namespace owners to make their own decisions for their own namespaces.
So isn't it as a cluster network policy admin, I would wanted to stop certain traffic even within the namespace to outside world, right? So let's say I don't want my across the board in my company, I have lots of tenants and I don't want them to go to xyz.com. So do I have ability to block that at the CNP level or not?
That is a very good question, and that is a very valid use case. But I think there was a bit of discussion about doing the outside cluster external traffic requires IP block, and IP block for ingress egress has different semantics. So we need to first nail down those semantics well before we use them in CNP as well. So I think that's why we've kind of descoped it, put it as a non-goal for external traffic. For specific blocks. But I agree that's a very important use case and we should be solving that. I do not disagree on that.
I agree with that. And the second thing to remember though, in a lot of deployments I've seen at least, usually there's some wall around the cluster non-Kubernetes related. That's just from what I've seen.
Except if you put the quality draw a sample topology, I mean, where you check IP blocks would typically be on your, I mean, egress out from the cluster, where you typically do a lot of SNAT, and on the external load balancer, so to speak, on the way in, right?
Yeah. Yeah. And
But,
so I think it's something that needs to be thought about further, but right now it makes more sense just to design for, you know, intra-cluster traffic.
You mean inter-cluster traffic?
Yeah.
Intra.
Or,
So I think
sorry.
Intra and inter namespace.
Inter namespace, and basically the use cases that we are trying to today solve for are all traffic within the cluster. So cluster internal, but nothing cluster external. Like no, we don't want to address those use cases with this proposal. But yeah, those are valid. That doesn't mean that they are not valid use cases. They're definitely valid.
Okay, so let me take another example. Let's say in a given cluster, right? I have n number of namespaces, and each namespace has you know, certain you know, example. Let's say maybe, you know, monitoring pods. So what I mean, I don't want, you know, certain you know, pod selector doesn't reach to the that monitoring pod. So, but this is across the board, right? For any namespace which is spun up in the cluster, would I have an ability to specify that the cluster you know, network policy, or do you say that, like, you know, hey, it's your namespace problem, and you know, you go and define it inside your namespace?
No, if as a cluster administrator, you know that all your namespaces or should not be, like, certain pods should not be able to talk to certain other pods, then you use a strict deny, and you should be able to write such certain strict deny policies, and that would affect your namespace traffic as well. So you should be able to do that, and you can do that. So this, the first 1A use case is kind of for that. So we spoke about the compromise pods, but you could also say that, you know, from namespace A, I want, you know, these DB pods to not be able to reach to monitoring pods. But so you should be.
Which is in the same namespace.
Correct. You could do that as well. You could, if your cluster administrator has that kind of view into the cluster, then they should be able to carve out. Yeah, that can be done. And your strict deny should take care of those use cases.
Okay, thank you.
Right. So I think so I feel like today we are only going to, at least hopefully, I mean, that's actually not a bad exercise, that, you know, we are at least agreeing on the use cases, and then we can look at samples. But the fifth one is basically now that we understand 4, which is stricter denies, but, you know, you want to delegate certain traffic patterns to the namespace owners. The fifth one is what happens when the namespace owners do not act on that delegated traffic. So let's say, as a namespace owner, the administrator has delegated the responsibility of public service to me, and as a namespace owner, I have not written any rule for it. So what should be the default disposition for such delegated traffic? Not for all traffic, but for such delegated traffic. As a cluster administrator, I could force administrators to write network policy by saying the default disposition would be deny, which means that any delegated traffic, if not allowed specifically by Kubernetes network policies, will be denied. Or I could let it be as is, you know. So, you know, if you don't write any rule, that means, you know, the traffic is allowed. So that's the default disposition kind of a use case. Are there any questions around this one?
Yeah, so Abhishek, so I was waiting for this, right? So the thing is, if you see 4 and 5 together, then I mean, I'm just putting my view here. Isn't it better to just call it a weak deny and let namespace admin do whatever they want?
So that's again talking a bit about implementation, right? Are you talking about, like, you're thinking in the terms of how I'm going to order these rules, right? We don't want to talk about that.
No, I know it's a little cross between implementation, but it's also a definition of action, right? So if instead of 4, which I'm calling strict deny but delegate, let's say I call it a weak deny. That means if I'm leaving decisions to namespace admin.
No,
but if the traffic
four is a little different because you strictly want to deny inter namespace traffic. There is no weak deny of inter namespace traffic.
No, but
That's
you're
the
leaving
strict.
some delegation, right?
If we're leaving certain, sorry, go ahead. Yeah.
No worries. I think what Nadim is saying that it's just like a wording thing where he understand, for example, weak deny as if there's no namespace network policies that regulates the traffic, then we have a default layer of this, which is specified by CMP, and if that's deny or allow. So in that sense, we could call it like a weak deny or weak allow, meaning that, you know, if all fall through, right? If the traffic is not captured by a strict CMP rule, and if the traffic is not captured by a namespace, the main network policy rule, sorry, not admin, like namespace Kubernetes network policy rule, then the weak rule sort of like gets hit.
Yes.
You mean the 5-year, you're calling it as a weak rule? I mean, is that what it is?
I mean, 5A and B, I'm just calling it as a weak rule. I mean, so.
Sorry, I understood you were talking about 4A and 4B, but you're talking about 5A and 5B, correct?
Yeah, I mean, 4A, in my opinion, is just a more sophisticated way of writing one with more grammar. But yeah, I was talking about like fifth A, right? If you call it a weak deny or weak allow, which comes in later, right? Then that can basically define use cases for A and B.
Yeah, I think that makes sense. Sure, yeah, but at least I think we understand. So is there any more confusion on the use case?
No.
All right. The sixth one is, again, we just spoke about like the external traffic. One of the things that we thought that, and this is something that Tim Hawkin brought up, was that with cluster network policies, we are aiming that this is going to be a guardrails for Kubernetes network policy, right? So, but Kubernetes network policies allow you to write IP block selectors for external traffic. Now, even though if you lock down a particular namespace, you can still write an IP block to allow external traffic and escape cluster network policy rules. So we wanted to see whether this makes sense or not, whether to lock down all or nothing for external traffic and not like have like a specific IP block selector or not. But this is something that I just wanted to document here. We don't necessarily have to solve it if everyone thinks that we can do it in a later stage, at a later stage. But I at least wanted to make sure that it's documented.
So one of the things which I think Sanjeev mentioned last time, right, about the ability to do all the things from a persona's perspective, right? So if we don't have IP block, then we are restricting the persona at cap level, right? It has to go and fall back at the namespace level to do something related to external traffic. We'll not be able to cover everything from the cluster admin's perspective.
So until we get another object, right? That's our look at this was like, we can't adequately solve all the use cases in a streamlined manner with one object.
And what's the problem sort of that we find the current IP block not good enough? So the idea would be sort of to have another way to specify IP blocks. And I mean, I'm a networking guy, right? So I still don't understand why we don't have some way to specify longest prefix matches for these things instead of a range and then exceptions. Longest prefix match is well established and it works both for V4 and V6. So build something like that instead.
And we could bring that into another, like, then we could focus a whole object only on the use cases of limiting cluster.
You could actually have these things become labels as well. You can specify them outside, map them as labels if we wanted to. It's really up to us.
So the current thing is that, I mean, yeah, all of these things are valid. At the same time, what has been sort of agreed loosely is that all ingress and egress use cases will be addressed separately, potentially with different CRDs or potentially via extensions to the same CRD. And all those ingress and egress use cases are the ones that rely on IP block, which mostly has been problematic on the ingress because of various natting operations. There's also egress natting operations. That's why it has been deferred. So for now, let's just focus on intra-cluster. And
I think sort of we should not. So today the cost to specify sort of a new policy type is very high. But I think in the end, we need to come to Kubernetes, where adding a new policy type has no impact on the CNIs and has very little impact on the system itself. We haven't even started there, but that's what we need to get to in the end, so that you can do these things and add them and add a new version of a network policy without impacting the CNIs, because they're just testing for communication, right? They shouldn't have to know how to break down all these policies into something that then can be used to build a firewall from.
Right. That's a whole problem too. But anyway, you Abhishek, Yang, you have, I know there's only a couple minutes left. If you want to just close up for today, like we'll continue this next Monday. But
I just want to quickly, I think the last 2 points are fairly straightforward, and then maybe we can close. Is that okay? Quick. I think
go for it.
The number 7 is like, whatever proposal that we come up with should be extensible in a way that we should try to be able to accommodate future extensibilities to the proposal. And this is not a use case, but it's a good to have that, the proposal that we have is extensible. So let's say an example is that, in future we decide to do IP block within the CNP, then it should be able to be, the proposal should be extensible enough to include that. And the final 8th one is like, it's like an all-inclusive policy, because typically you're going to have a mix of use cases, right? So as a typical use case for your cluster would be, you want to deny or inter namespace traffic, but you want to strictly allow traffic to core DNS pods in kube systems and system namespaces, and then delegate intra namespace and traffic to public service to developers. So this is like an all-inclusive policy you should also be able to carve out with the proposal. Without having too much of mental trauma associated by writing policy. So that's I think these are the use cases, and then I think we have kind of gone over all of the use cases, and I think now everyone at least understands the intention of the use cases. And if we have left out any particular use case that is not covered by 127, then do let us know. And I think next week we can talk about how the implementations sample specs can be used to solve these use cases.
So Abhishek, can you share these things for commenting so that, maybe we can help in giving some examples?
Yeah, I'll add this the link to the agenda today.
Great, thank you.
So do we want to have action items for next Monday?
Sure. What are you thinking? I mean, I was thinking you just want to finish your presentation. And...
yeah. So no, I think it was like the action item for this week was to run through these use cases, agree upon those intentions, and then take a look at the sample specs for the 3-action proposal and for the priority-based proposal. So I think so, Sanjeev, if you agree upon these use cases, so maybe we can have like a priority-based sample YAMLs, and we can have 3-action-based sample YAMLs to look at next week, and that way we document them and we see. And if there are other implementation specifics, we can speak about that next week. Is that fair enough? Because I don't want to just show the 3-action YAMLs, because I think majority, it seems like there's like either a 3-action or for 3-action or for priority based. So it will be good to see YAMLs for each of those use cases on both the proposals.
Yeah, I agree. I totally agree. And I think if there is any use cases we are missing here, like that is probably the highest priority.
Yeah, definitely. I think the first thing we'll do is like, let's brainstorm, see if there's any missing use cases that we have not yet documented and add them in, and then we can discuss the samples.
Great. Well, thanks so much for doing that, all that today and preparing all that. Please share that link in the agenda. And I hope everyone has a really good day, and let's get some more comments on this and try to iron some stuff out by next week.
One more quick thing is that now we've got 3 places of use case documentation. We've got the original KEP, we've got the network policy, API, repo, docs, and we've got the slide deck. We should sort of try to keep use cases in one place. But
yeah,
for now,
whatever I think is decided upon should be reflected in the network policy API repo for future reference. I think it just started moving so fast that it almost was easier to do via a slideshow manner. But yeah, it's all a learning experience. We want to get better at this. So that's an awesome feedback. We need more of it.
Okay, thank you.
Okay, thanks everybody. Great conversation. We'll talk to you later. Bye.
Thank you very much.
Thank you, everyone.